Welcome to Module 4. In this module, we'll review different database products and talk about managed services. Managed services allow you to take advantage of having AWS do the undifferentiated heavy lifting associated with common services such as relational databases or caching services. Let us start by describing some of the differences between a relational and a NoSQL database. A relational database has a well-defined structure or schema. The structure is defined by rows and columns. In a NoSQL database, there is a partially defined schema. A JSON document is an example of NoSQL data. Another important difference is to note that relational databases scale vertically, whereas NoSQL databases can scale horizontally, making them more flexible. Some of the factors one must consider when choosing a database are: what is the structure of data being stored? What kind of queries would the database receive? What is the total size of data, and what is the size of each item in the database? And what is the frequency of data access, etc. Amazon RDS is a managed service that supports some of the prominent relational database engines. Many relational database administrators, or DBAs, spend their time installing, maintaining, and patching their databases. They also spend time improving their business by optimizing data. This helps differentiate their organization by focusing on their core competencies. Most DBAs would agree that the time they spend building functionality and improving their data for their business is where they find the most value on the job. Amazon RDS is the answer to this. It offers the ability to offload all that undifferentiated heavy lifting, the installations, patching, and other maintenance tasks, so all you have to do is the work related to the growth of your business. Amazon RDS is a cost-efficient and resizable solution. It allows you to offload the time-consuming standard database administrative tasks while giving you the full capability of MySQL, PostgreSQL, Oracle, SQL Server, MariaDB, and Amazon Aurora. Each one of these databases, depending on the workload or use case, allows you to get access to the capabilities of a relational database without having to manage setup and maintenance tasks. Amazon RDS is easy to set up, operate, and scale because you're offloading this work to AWS. Amazon RDS also manages patching and backups, so you don't have to do that work yourself. You benefit from the flexibility of being able to scale the compute resources or storage capacity associated with your relational instance via a single API call. An RDS instance is like an Amazon EC2 instance. After you select a database engine, you can create multiple databases on the instance. Your RDS instance can also be launched inside a VPC, securing access of your system. RDS supports both automatic backups and manual snapshots. An automatic backup follows a journal-based backup method. It gives the user greater granularity, but it might take a long time to restore some backups. A manual snapshot is like an Amazon EBS snapshot. It is an independent copy and supports incremental backups. RDS snapshots can be migrated to another AWS region, after which a new Amazon RDS instance can be created from the snapshot. Amazon RDS supports a wide variety of security options. Amazon VPC prevents external users and systems from accessing Amazon RDS instances. AWS IAM policies can be used to restrict certain operations. For example, if you would like your developers to have the ability to create small Amazon RDS instances and prevent them from creating large DB instances, AWS IAM can help. Amazon RDS supports data encryption for data at rest and data in transit. On Oracle and Microsoft SQL Server RDS instances, transparent data encryption is supported. With a multi-AZ architecture in place, should one of the availability zones fail, the database would eventually be available for application access. Like any database, some of the common best practices for Amazon RDS are to ensure multi-AZ deployments are configured, RDS instances are hosted in private subnets, maintenance and backup windows are properly configured, and depending on the expected database performance, ensuring the right instance type, storage capacity, and IOPS are allocated will ensure user satisfaction. Setting up a time to live on application servers to 30 seconds will ensure a failover from the master to standby transitions smoothly. Let's look at a demo of Amazon RDS. On the management console, let's click on RDS. To create an Amazon RDS instance in an Amazon VPC, we must first specify which subnets are preferred. We can do this by creating a subnet group. We click on Create DB Subnet Group, give the subnet group a name, a description, and select the Amazon VPC inside which the Amazon RDS instance should be created. For the availability zone section, let's select the availability zone and the corresponding subnet that Amazon RDS should use. This ensures multiple availability zones are selected. Moving on, let's click on Instances and Launch DB Instance to create a new DB instance. Amazon RDS offers a variety of database engines. In this demo, we will use MySQL. Let's choose the production option for a multi-zone deployment. We can also choose the version of MySQL, and like Amazon EC2 instances, we can also select a preferred instance type. We can specify if multi-availability zones should be configured, along with the storage configuration. Let's provide a username and a password for user login and click on Next. On the Configure Advanced settings, we can specify a VPC and a subnet group that should be used. We can specify if the database needs to be a publicly accessible one and what security group should be used. As this is a MySQL database, I will use a MySQL-based security group. We can give the database a name, specify parameter configurations, and enable encryption if needed. We can configure backup and maintenance if needed. Some of these operations are similar to creating an Amazon EC2 instance. Finally, we click on Launch DB Instance. This step should take some time to complete. While the database is being created, let's switch to the Amazon EC2 console, where a web server has been created with some user data configuration. The user data configures a web server and downloads a sample web page. This web server can connect to the DB instance once it is ready. Let's click on RDS and enter some of the DB values while we wait for the DB to be created. The DB instance is now ready with an endpoint. Let's copy the endpoint and paste it in the web server page. Making sure we get rid of the colon and the port number at the end of the string. Let's now click on Submit on the web server page to connect to the DB. We can now interact with the database by adding or editing some entries in the database. This is the end of the RDS demo. Let's now move on to the next section. Amazon DynamoDB is a fully managed NoSQL database service. An Amazon DynamoDB table consists of items and attributes. In this example, a table called music has been created with multiple attributes, namely artist, song title, album title, year, and genre. Notice the number of attributes in every item is not uniform. Some have more and some have less attributes. The only attribute in a table that is mandatory is a primary key. The primary key has to be unique throughout the table. Further, there are two types of primary keys. Partition key-based primary key, where the single attribute is unique, or a partition and sort key-based primary key that forms a unique combination. Provision throughput enables administrators to specify the kind of performance needed in terms of capacity units. A query operation helps administrators search from an index based on a partition key. If you would like to search for information that is not indexed, then you could consider using a scan operation. Scan operation looks through all attributes in a table. Let's now look at an Amazon DynamoDB demo. We start by selecting Amazon DynamoDB on the management console. Creating an Amazon DynamoDB table is simple. On the DynamoDB dashboard, let's start by clicking on Tables. We then click on Create Table and name the table as Music. For the primary key, let's choose Artist as the partition key and add a sort key with the label as Song Title. We could simply click on Create Table to create a table. However, let's uncheck the Use Default Settings option. Amazon DynamoDB supports auto-scaling, but for this example, let's define the read and write capacity units as 1 respectively. and that is all you need to create the table. The table should take a few minutes to be ready. In the meantime, here is a sample JSON document with some entries such as a song title, artist, album title, etc. We will use a batch write option to write all these entries into the table using one single command once the music table is ready. Now that the table is ready, let's click on the Items tab and refresh to verify that the table has no data. On the terminal, I will use the batch write item command to write the JSON data into the table. The operation was successful. Let's verify the same on the management console. And after refreshing, you see all the data in the table. We can use the query operation to search based on primary key values or a scan operation for any attribute in the table. This is the end of the DynamoDB demo. In summary, if you are looking for a managed relational database service and the database engine you are looking for is supported by Amazon RDS, then Amazon RDS would work well. If you are looking for a managed NoSQL database, then Amazon DynamoDB is a good choice. Amazon RDS and Amazon DynamoDB do not support operating system access, and nor do they support installing additional modules. Users would, however, have DB admin access. If you need access to the operating system hosting your DB, or you want to choose an unsupported DB engine or version, then hosting a database on Amazon EC2 would be ideal. Thank you for listening. We have now completed Module 4.